As we may have seen that every once in a while when we divide big numbers by big numbers, we get this weird E thing. We saw that when we looked at the last number for 14 last E. I divided 5.01 grams by 1,002,000 molecules, and I got this super tiny number. Let's go ahead and type it into our calculator so we can see it. 5.01 divided by 1,002,000. I got this number. Probably the same number you got, right? This 5e negative 5. Oh, Samantha, you can go. This is how my calculator reads scientific notation. We're going to find out today that 5e negative 5 is actually 5 times 10 to a negative 5. The E is how I tell my calculator I'm working with scientific notation. Does anyone have a calculator in hand? I'd like for you to get a calculator in hand if you don't have a calculator in hand. Why do I need to worry about scientific notation? How do I type this into my calculator? Why do I need to do this? Let's take a very big number, Avogadro's number, which is 6.022 times 10 to 23. And I want to divide that by itself. In theory, if I divide a number by itself, what is my outcome? 1, right? It can only go into itself one time, right? Let's type it in our calculator the exact way we see it here. 6.022 times 10 caret 23 divided by 6.022 times 10 caret 23. I hit the enter button. Oh, my calculator is telling me when I do that, I get 1 followed by 46 zeros. That's an incredibly large number. What happened? It's Avogadro's number divided by Avogadro's number. I know it as one number divided by itself. My calculator does not see that. My calculator sees 1 function, 2 function, 3 function, 4 function, 5 different functions happening at the same time. What can I do in my calculator to let it know that 6.022 times 10 to the 23 is one thing? I'm going to use this function, this EE function right here. Because the E followed by a number is the same as writing times 10 to whatever that number is. So let's do it again. 6.022. Now this is how you're going to get the E function. You're going to hit the yellow second button. You're going to see a little arrow point up here, right? I'm going to hit this little comma button right here that's above the 7. Mine's worn off due to age. I press it, I get the E function. Now, I'm just going to type in whatever the exponent is, the power of 10 is. 2, 3. Oh, too far up. Divided by itself. 6.022. Yellow second button. E, the button above the 7. 2, 3. Now, my calculator realizes that's one number divided by one number. It also works in negatives because we've dealt with some really tiny numbers, right? And we know the smaller our number is, that the power of 10 is going to be negative. So if we look at our weight of a proton in pounds, 3.69 times 10 to the negative 28. Divide by 3.69 times 10 to the negative 28. These are pounds. How do I get the negative in there? I do the exact same thing I started off with. I'm going to type in whatever number comes before the times 10, that goes in front of my E. So 3.69. Shift second E. My exponent is negative because I have a very tiny number, right? I'm going to hit the negative button first. Negative 28. Divide by 3.69 second E, negative 28. Any number divided by itself always gives me 1. If I didn't, 3.69 times 10 caret 28 divided by 3.69 times 10 caret negative 28, I get some crazy ridiculous number. The calculator is telling me I'm putting it in wrong. If I get something outrageous. Remember, we hit the second, the yellow button first, then the button above the 7, which is like, it looks like a comma, E, and it always comes up with the times 10 function. Like I said, E represents times 10. If it's E negative number, then that equals times 10 negative number. Okay? Let's put to practice. On the back of your homework, I had a couple questions. I'd like for us to walk through number 17 together, and I'm going to have you guys do 18 by yourself. So if you get a head start on me, you can go ahead and knock that one out. So 17, parentheses, 1.8 times 10 to the power of 5 times 3.6 times 10 to the power of 2. Now if I put that in my calculator, 1.8, 1.8 second E 5 times 3.6 second E 2, I get a super long number. Now the parentheses help me out here because technically if I use the parentheses, I could write the formula out exactly as I see it. Times 10, caret top 5, close caret top, caret, parentheses, 3.6 times 10, caret 2, close parentheses. I get the same answer. Which one was easier to do? The first one or the second one? The first one. The less buttons I hit, the less likely I am to make a mistake. The less likely I am to make a mistake, the more likely I am to get the question right. So I'm going to get a number. 6, 4, 8. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Is that my final answer, though? I'm doing multiplication. How many sig figs is my least number of sig figs in my question? How many sig figs is there in 1.8 times 10 to the power of 5? 2 sig figs. 1 sig fig, 2 sig figs. Because remember, anything besides the times 10, those are all sig figs. How many sig figs are in 3.6 times 10 to the power of 2? 2. How many sig figs do I have right now? 3. So I got to fix that, right? 6, 5. What am I going to do after that rounding bar? Yep. If I owed you $64 million and gave you $65, I want to add zeros in those spaces. Two, three, four. That's a terrible choice that guy's making. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Or I could just, instead of writing out all those zeros and making sure I put everything down, 6.5 times 10 power 7. Which one's easier to write? Scientific notation or standard notation? Scientific. Work smarter, not harder. Very little I had to do in order to correct that. I'd like for you to work out number 15 on your whiteboards. I'm sorry, 18. Like you do number 18 on your whiteboards. Man, where did 15 come from? I'm mixing numbers up. I'd like for you to write. I want you to write two things on your whiteboards. I want you to write the unrounded answer. So that's what you get straight from the calculator. And I want you to write the rounded answer underneath it. I want the unrounded answer that the calculator gives you, and I want you to round that answer if you have to. And while you're doing that, I'm going to go ahead and write it up myself. Two things that are going to be on your whiteboard. It'll be your unrounded answer and your rounded answer. And don't leave it in E. Tell me what the E stands for. It's great that we understand the E stands for times 10 to a power. But I also want to get some practice of taking something that the computer gives me and putting it in the way I'm going to answer my questions on my quizzes and my tests. Who is Brad? Just smacking me a bunch of emails. What is it? Yo! I'm not on my door. Great. Sure, I can do that.
I need that.
Yeah.
There's this. That equals this too. So that is exactly
Make sure you write your final answer on your whiteboard. 2 answers should be on the whiteboard. The unrounded answer and your rounded answer. Does everybody have an answer to where it show?
I did 4.7.
Let's do it. 5 seconds. 5, 4, 3, 2, 1. Show me what you got. I'm sorry. Well, I saw what you're doing, so we're solid. Because next time, make sure it's on. Put it on the paper for me. All right. Okay. Okay. Oh, Lord. All right. So, we were absolutely right about the round answer. So if I put in my calculator here, everyone got the unrounded answer right. 2.585 times 10 to the 10th power. Perfect. How am I going to round by sig figs or decimal places right now? Sig figs, right? Because I'm multiplying my numbers together, right? What's my least amount of sig figs? 2. So we rounded at the right place. 8's big enough to push my 5 to a 6, right? Do I put any zeros behind my rounding line? No, because I'm already in decimals, right? If I add zeros here, I make them significant. Times 10 to the power of 10.
That's it.
That's it. So if I did it, so 2, 5, 8, 5, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's my number. Just so we can see that we don't change the exponent, the power of 10. So as if I wrote my number out in standard notation, right? I still just want 2 sig figs, right? So my 8's still big enough to push my 5 to a 6. So that's 2, 6. Did I change the size of my number? I didn't, because I'm going to still fill these spots with zeros. I didn't change my number by rounding. I just changed how much of it was significant. That's all. So when you get a power of 10, leave that here. You're just changing this part right here. Because this decimal didn't move up 2 places. It stayed the same. Does that make sense? Okay. We did 2 multiplication ones. Let's do a division one. Let's get a negative one. I want you to do number 22 on your whiteboard. And again, I want for 22, I want the rounded and unrounded answer for 22. And I'll leave this right here for us right now so you guys can see what I want. Slide this over fast. So remember, I want 2 things. I want the unrounded answer, and I want your rounded answer. Yeah. So we're looking at number 6, right? So whatever number comes before the 6, 40 times 10, that's a 6. Sorry. 6, right? Now the times 10, that's my shift E. And then the exponent here, power 10, I'm just going to type in 10. Now, what am I doing? Divide. And then 2. Shift E. No, it's 0. There you go. That's it. And then you hit the enter button. Let's see what you got. Let's see what you got. You're adding a times 10. Don't put the times 10. Because the E represents the times 10. So try doing 6E 10
So
divided
this is
by.
the 10 and times?
Mm-hmm.
Okay.
The E represents the times 10. Yeah, so you don't need to carry. So what you do, so do 6, put in E, and then here's what put in the 10. That's it. Then divide that by the next number. Yeah, because the function already has that, knows what that is. The computer recognizes the E as the times 10, the number behind it as the power of 10 that the number is. Yeah. No, it's definitely it wouldn't be 3 followed by a bunch of zeros, to be a bunch of zeros followed by 3.
Oh, his negative 20 is direct way.
You have that extra,
Got it. Miss, I need to put. I know que bonito. Negative one, I think it's like this. Did you get this? I like negative 20. Yes, it has to be. Porque así salió en el teléfono.
Okay, let's see the whiteboard. Let's see the whiteboard. Let's see what you did. Let's see how you did, ladies and gentlemen.
And that's how we wrote about it.
Ooh. Sir, look, I understand that you want me to get my eyes checked, but you gotta write a little bit bigger than that.
That's your problem?
No, I'm trying, no, put it back up, is this tiny? Alright, let's take a look at it. Alright. So, if I put in my calculator, number 22, give me a quick second. Let's clear this out. 6, shift E, 10. Divided by 2, shift E, 30. Gives me a grand total of 3E negative 20. We agree with this, yes? Okay, so let's revisit this. So when I'm to write this out, It's 3 times 10 negative 20. So the E represents the times 10. You don't have to put the multiplication symbol in there. The calculator knows that E means this. Whatever number comes after the E, the calculator knows that that is the power of 10. Be careful. A lot of people who are getting it wrong were either adding extra functions in here, like they're adding 6 times E10, or I saw this one too, 6E caret top 10. The function is already programmed for you. The reason why we do it that way is because less keystrokes means less human error. Let the calculator do the brunt of the math. We're just cleaning up the end of it. Question, do I need to round my number? No, because I have 1 sig fig, 1 sig fig. Guess how many sig figs are my final answer? 1 sig fig. I don't have to round anything.
Is that what you meant? For the answer?
You'd write this for the answer.
Okay.
This is what I'm going to expect to see on a quiz or a test. I need you to understand that the E represents the times 10, and the number after the E is my power of 10. Let us do one more before we start looking at the homework. I'd like for you to do number 24. It's 24, that is 3.45 times 10 to the 23 minus 2.34 times 10 to the 24. You're going to do the same thing again. You're going to give me the rounded answer, your unrounded answer, and the rounded answer. I want both.
Maybe.
At noon, Nicholas get up later. There's a good chance of it. I want 2 numbers on your whiteboard. I want what the calculator told you. I want the correct rounded answer. I should have 2 answers on my whiteboard. I need to remember what rule I'm using. So, five, shift,
I'm looking to do for you do this one.
5,
Yes. Like, no, you don't put that in there. You put it on the, so,
23, isn't it?
oh. Something like that, bro.
Yeah, that's how it's like, so 3.45 should equal, it should be 5 times 10. What's the power of 10? Or is that 3.45?
So you have to do something. So,
No, it's 23. And minus 2.34 shift E
24.
24.
yeah, head that times 10 I think it doubles the effect. And you get the wrong answer. All right. Let's see what you guys got. Let's see what you got. All right. I just want to see what we got. See what we got. See what we got. Just checking. We're all good. All right. All right. Let's look at it together. So I turn on my calculator. Ba-ba-ba. All right. So first thing I do, 3.45. My times 10. Second E. 3 minus 2.34. Second E, 24. This is what I'm going to get. Negative 1.995 E24.
I'm telling you, I told you people.
Do we agree with that answer? So if I was to write that out, that'd be negative 1.995 times 10 to the positive 24. Now, am I looking at sig figs or am I looking at decimal places for rounding? Look at decimal places because I subtracted my numbers. So I'm counting decimal places. I count 2 over here. I count 2 over here. 1, 2. Okay. Is the 5 big enough to push my 9 to a 10?
Yeah.
9 plus 1 is 10. 1 plus 1 is 2. If I left it as just 2, my number is less precise than my question. I want to have my final answer be as precise as my least number. My least number has 2 decimal points. I got to have 2 decimal points. If my least number of decimal places is 0, that means that my final answer will just have 0 decimal places. So be careful when you're rounding. Now, I'd like for you to look at your homework real fast. This is it right here. Practice using significant figures in calculations. There are 10 questions in total. Notice that question 10, you are dividing numbers that are written in scientific notation. If you do not have a copy of this, go grab a copy of this. First thing I want you to do, at the top of your paper, we have to make a small correction. In our reminder section, on your piece of paper it says, for addition and subtraction, round to the least, I want you to cross out precise place, and I want you to write amount of decimal places. Multiplication, division stays the same. I'm looking for the least amount of sig figs in my question. That's how many sig figs my answer will have. When I'm looking at addition and subtraction, I'm looking for least amount of decimal places. Now we take a look at some of our questions. We'll see that sometimes we're doing 2 things. We got a lot of just multiplication, division. I'm adding three numbers together. I'm multiplying three numbers together. I'm adding three numbers together. Let's look at number 3 together, and that would be the one that we finish on of how we would best answer this question. Number 3. 12.01 milliliters plus 35.2 milliliters plus 6 milliliters. You're going to want a calculator out when you do this stuff. 12.01 plus 35.2 plus 6 gives me an unrounded answer of 53.21. What's the units I'm working with? Milliliters. MLs. Based off of my question, how many how am I I'm clearly looking at decimal places.
Oh, no, 1.
How many decimal places will my final answer have?
0. 0.
1, 2, 3.
How many are in 12.01? There's 2 decimal places here. How many are in 35.2?
1,
How many are in just in 6?
0.
0,
Which one's the least number?
0.
0.
Is my 2 big enough to push my 3 to a 4?
No.
So my final answer, 53 milliliters. You're going to do that for all of them. There's a couple other ones where you're going to have like 2 or 3 numbers, same function, but you have to remember which rule you're working with. Am I working with the decimal place rule? Am I working with sig fig rule? Which one am I going for? I'm going for 1 to 2. If I get these things locked in my head now, my life gets so much easier. Go ahead, gang, grab your phones, pack it up.
Mr. Weissman.
I might have to stop here.